let's have a look at what is VPC. So the first construct within AWS is your VPC. So let's say this is your whole of your AWS. If you say that this is your AWS, the first construct that you have is your VPC. So which is, it will form a very broad level inside. So let's put it as blue, and that is going to be your VPC. Inside your VPC, you will have many sort of different applications, many sort of infrastructure. We'll have a look at it, but not all the applications and not all the infrastructure is inside VPC. There are multiple AWS services which are outside the VPC in here. So, for example, you've got AWS S3 buckets and all, IAM permissions. These are all outside the VPC and they would stay over here. But most of the infrastructure and applications that you would see would be inside VPC in here. Now, inside your VPC, the first thing that you will have is, let me go to the page. So when you see inside the VPC, the first thing that you will have is your availability zone. So your availability zone would be somewhat like that. So if I mark that as an availability zone, I think it's better to put it like this way. So inside your VPC, you will have the availability zone spread across. And this availability zone, inside this availability zone, you will have something called as a public subnet, which is your public subnet in here. And I'll tell you in a bit of detail as to what these public subnets are. And you will have a very similar private subnet. So that is going to be the construct that we will be talking about. And this is your availability zone. Now let's have a look at what is a subnet. So you've got a region, you've got a VPC, you've got a public and private subnet, which is spread across, the subnets are spread across the availability zone. Now, in a subnet, so subnet is a space inside VPC, which is specifically allocated for your network traffic. So when you say there's something called as a CIDR block, right? So let me explain you what a CIDR block is. And let me see if this presentation can support me with CIDR block right away. All right. So CIDR block is something which is, it's a classless interdomain routing. So a complex name for something which is not as complex. So it's a method for allocating IP addresses. So when you select a subnet it's a collection of IP addresses that is allowed to reach inside a specific zone. So you have got, let's say you've got a subnet called as, so let's assume that you've got a subnet as 10.0.0.0. So you've got a range of IP address, and there's something called as a subnet mask, so which is /24. Now let me explain what does that mean. So if you see in this diagram, so a subnet has got a range of IPs. So a subnet is comprises of your CIDR block, and a CIDR block is divided into your IP address and your subnet mask. Now, let me explain what does this IP address and subnet mask means. So what a subnet mask means, that it's a, mm, let me just, okay. So it's just that one thing is, okay, let's see. So a CIDR range consists of two components. The first is your base IP, which is your, let's say, for example, 10.0.0.0. And there's a subnet mask. Subnet mask will define how many bits can change in the IP. So, for example, a subnet mask of 0 would correspond that there can be one IP address which can be allocated. Now, how it works is that if you have got an IP, and I'll show you this I'm just trying to make it as easy as possible. So, for example, you have got a subnet mask of 10.0.0.0 and a subnet mask of 32. So it starts from the upper end. So a subnet mask of 10.0.0.32 would mean that, so the mathematical equation is 2 to the power 0. So that would mean how many IPs are here? So that equals 2 to the power 0 is 1, right? So one IP address. So inside this subnet, if you have a subnet of /32, that means there is a one IP address which can be allocated. So that would mean that when you are hosting a computer or an EC2 instance in here, so only one IP address can be allocated if you have a subnet of 32. But if you have a subnet of, let's say, 24, that would mean, so how it works is 32 minus 24, that equals 8. And number of IP addresses will be 2 to the power 8. So 2 to power 8, that equals 256. So it's a very mathematical calculation. You don't have to remember it always. There are many websites which will give you exactly what is what are the number of IP addresses that correspond to, for example, for a CIDR range of 10.0.0.0/24, how many IP addresses would it cater to? So it will tell you that it will give you 256 IP addresses. If you have a 10.0.0/16, so that would mean around 65,000 IP addresses. So how your VPC and subnets are actually divided is, so your whole VPC will have, let's say, a CIDR range of 10.0.0.0/16. So that means, so if you have your VPC here and your VPC has an IP address of 16, that would mean your whole this VPC, this blue section that you have, it can accommodate around 65,000 computers, right? So that is equal to 65,256. So which I've taken it from 65,536. So that means your whole VPC will have around 65,000 computers, out of which you will have to slice the subnets, right? So your subnets for 24, and as many as resources that you create, it should not exceed these many IP address allocations. Now, I'm not sure if I'm just confusing it for everyone. Can somebody tell me if I'm confusing anyone?
It is clear,
No,
Saurabh.
it's clear.
Okay, all right. So yeah, I was just worried that I'm just confusing with these numbers. But
Can you please?
what you essentially do is that once you have the VPC and the number of computers in here, you are only allowed to slice it with as many computers. For example, this subnet will consume 256 IP addresses. If you have another private subnet, which is let's say 28 and not, so this would mean 32 minus 28 equal to 4. So 2 to the power 4 is equal to around 16 IP addresses. So this subnet will have just 16 IP addresses. So out of 65,000, your subnets and all these different subnets that you create, they will start allocating different IP addresses, and these many computers are allowed. And just understand that your EC2 instance will have one IP address. So if you have another EC2 instance in here, and if you have consumed all 256, you will not be allowed any more, right? And you cannot edit a subnet once it is created. So, all right. So this is exactly what it is. So slash 32 allows for 2 to the power 0, which is a one IP. And then you will have slash 31 allows for two IPs, four IPs, and subsequently, and so on. So that's the range. And having an understanding of IP addresses and CIDR range is very important in terms of networking, because what you're allowing inside the subnets, what you're not. So that is very important. So yeah. So now in here, so what we have done is, so we created an AWS account. Inside AWS, you've got VPCs, you've got availability zone in here, you've got public subnets, and you've got private subnets. Inside these public subnets and private subnets, you can start creating your EC2 instances. And we'll do that in a moment as well. But this is public subnet is something which is exposed to the internet. A private subnet is something which is not exposed to the internet, and we'll have a look at how to create all these public and private subnets, and what it actually means by exposing to the internet. Right. So now in here I created something called as EC2. So for those people who do not know EC2, EC2 are just their computers or Linux or any other sort of machines which are provided by AWS. You can have your own different image of, let's say, a Linux machine, and EC2 are nothing but the instances that are created over there. So let's go and just, I'll not be going completely into EC2, but there is service called as EC2 in here in AWS. Out of hundreds of services, this is one of the key service that is being used. Once we'll have a separate EC2 session maybe next week or so. But all what you can do is you just go in there, you launch an instance. It'll ask you for n number of parameters, and you can launch an Amazon Linux machine or a Red Hat Linux machine or any other machines. In the previous sessions as well, I showed creating all these different machines. It's a very intuitive whatever you want to create, and your machine will be launched. When you are launching up your machine, so it'll ask you where you want to create the machine. So like which VPC do you want to create, right? So it'll give you all these. It'll ask you all these different types of questions. But so essentially, this is nothing but let's assume that it's a Linux machine or it's a Unix machine or Windows machine living inside the subnet. Now, what it means inside a public and a private subnet. A public subnet is something which is internet facing. So for example, if you are hosting a website, so an example is if you are hosting a website, so you want your website to be accessible through your public subnet, right? But there are a few mechanisms on which they differ both in terms of routing. So the first thing that you see is your public subnet is connected directly to your internet. So let's say if you have, let's see if I'm able to get something called, okay. So you've got this internet here, right? So your internet will is allowed to reach your public subnet, right? So your internet is allowed to reach a public subnet. So any computer which is all over on the internet. So let's assume for a moment that this is a computer and it's trying to come from the internet. So it will be allowed to go to your public subnet. So there is no restriction for your public subnet. But your public subnets by themselves are very secure. So any traffic coming from your public to private subnet, that will have to be extremely monitored. So not all the traffic is allowed to come from here to here. So it's logged. So the traffic in here directly is logged based on the different IP addresses, and also it's a very logged traffic in here. But your internet can reach over here with something called as internet gateway. So there's something called as an internet gateway. So your internet gateway is located at the edge of your VPC. So this is your internet gateway. Let's remove that because we know. So internet will go, any public computer will first go on to your internet gateway. It will hit, and then from internet gateway, it is allowed to go onto a public subnet. So similar way, it's a bidirectional traffic. So if you see, so and for the same way, your public subnet computers will be allowed to go through your internet gateway as well. So let's have a look at in AWS as to what does it mean, right? So when you go inside the services, so let's go on to an AWS and look for your VPC. So that's your VPC. So if you click on your VPC, so in here you can see the VPC dashboard, right? So if you see in here, there are a lot of different things. So you've got VPC, you've got subnets, you've got route tables. We'll talk about a few essential items in here, and I'll not try to confuse you with a lot of different things, which is not really important at this point. But the first thing that you see in here is VPC. So how do you see the VPCs? So if you already have some VPCs created, for example, I created a couple of VPCs in here but otherwise, if you want to create a VPC, all you have to do is you press the create VPC. Now, what does creating VPC means? That you are inside AWS, and this is the blue thing is something that you want to create in VPC. So for example, if I want to create a VPC with the IP address of 10.0.0.0, and that is, so this is what it means inside VPC. So you're creating a VPC only. Let's say I call it as my, let's say I call it as my prod VPC. So inside that, it asks you for what sort of CIDR block allocation. So we had a look at the CIDR blocks. So you can specify an IP address. So that is where to start with. So for example, you say 10.0.0.0 slash, and you want to allocate a subnet mask to it. Now, what was the subnet mask? So this subnet mask would define how many computers do you want inside your VPC. Now, it doesn't cost you anything to define 65,000 computers or 16 computers. So it's better to have a good amount of chunk in the VPC itself when you're creating the first construct of your AWS. So which is, let's say you say 16. Now remember, the lower you go, the more number of computers it has. Because when we calculated it over here, you see, if you make it as 32, it would mean that only one computer is allowed. If you make it as 24, it would mean that 256 computers are allowed inside these. And each resource will have its own IP address. So you have to be very careful in allocation. So now IPv6 we don't want to go in there. IPv6 is a separate IP address range in hexadecimal format, which will allow of millions of computers inside IPv6. Not many organizations are using it currently, but most of them are still going with IPv4. So we just go with. So this is as simple as creating a VPC. So that's the first construct. So it gives you a VPC ID. Your VPC is available, uh, and there are some of these attributes we'll be discussing as we go. Right. So VPC is created. Now, if you look at your VPC, it will say that my prod VPC is already available. So you've created already the first construct which is available in here. The second thing that you want to create is a subnet. So when you go inside a VPC, so this is what we are trying to create now. So we created the VPC. Let's create a public subnet and let's create a private subnet. So these are the two types of subnets that we want to create. And then we will have all these different internet gateways and all routes available. Now, before we create all these different subnets, I want to tell you something about the routes. So we had a look at CIDR. We had a look at, okay, one more thing. Yeah. Public versus private IP addresses. So if you see a private IP address, a private IP address is something like an IP address of a website. So if you see here, so an address of a website is very different than the IP addresses that you see inside in here. For example, if you want to check the IP address, let me see if Google gives me. Let's see if I ask what's my IP. So if you see, so that is my IPv4. No, bad thing. So
First link should give you.
normally it shows you, right? So
that's what.
Yep. So this is an example of a public IP address. For example, 124.184.112.93. So that is the IP address of my computer. But any website that you see, it will have its own different unique IP address. So anything that is accessible in public will have its own unique IP address. So these IP addresses can start up with any number. So for example, it can be 192, it can be 195.203.44.31. So it can be anything. But if you see the private IP addresses, the private IP addresses are very restricted. So they only start up with a specific number. So for example, they can start up with 10 dot, and I'll put x.x.x just to mark up any number. Or they can start up with 172 dot that, or they start up with 192. 192 dot, if you have done any sort of configuration in your home, all your home networks start with 192. So especially they start up with 192 dot. So if you look at your router in your home, it will probably start with 192.168.0.1. So this is your home IPs. That's what it corresponds to. 10.x.x, all the corporates, all the big networks, they all start up with. So this is your home IP. This is your home network. 10.x.x.x, they always start up with all the big corporates. So big that you see. So they all start up with 10.x. So your office or any organization, they will have these range of IPs. Your 172. So this is the AWS that AWS keeps a default VPC in that range. So this is something which is not accessible to you. It's an AWS default. But you would see that all the organizations, they will have 10.x, your home network will have 192, and your public domain is anything other than these. So it can be 195, or it can be 204, starting with any of these numbers. So that's what your public and private IPs are. So private subnets will have your EC2 instances only operating at 10.x level. So your if this your EC2 is private, so it will have only one type of IP, which is your 10.x. But if you have an EC2 which has a public exposure, it may also contain a public address, which is something like 205.33.2.11. So it may have this sort of IP, which and any public computer, and this is not really, let's take this, yeah, take that. So any public computer which is trying to connect to your EC2 instance at 205.33 will be able to connect to the public subnet. But if the same computer tries to connect to an IP address in here, which is 10.0, let's say this is 10.0.1.1, it will not be able to connect. So this connection is not happening, right? So that is what is private subnet, where any of the public computers will not be able to connect to your EC2, but your public subnet will allow these internet-based computers to connect to, because they are hosting something which should be applicable to the public. Now, these can be your external load balancers. These can be your EC2 instances. And we'll have a look in this session as to how do actually all these computers connect through the internet gateways, the routing tables. Right? Okay. Now, before we actually go into the depth of it, there's also something called as VPC peering. Now, I just want to touch base on this subject because it's not that an organization will just have one VPC. There can be multiple VPCs, right? So you can have multiple VPCs for different purposes. So for example, organizations can have something called as a dev VPC. So where you will have only a development purposes account. So let's call it as VPC dev. And an organization can also have something called as a VPC test. So normally all the infrastructure, all the networking, they will be pretty much separate for these different dev and test VPCs. But it's also possible to connect these VPCs with themselves. So that is where you have something called as VPC peering, which comes into picture. So come on. And this is a bidirectional arrow. So what VPC peering means is that you will have something like another, let's say a private, for example, you have just this private subnet in here. Okay. So so you will have another private subnet here, similar sort of constructs that you will have. Okay. Now you want the computers in this private subnet to talk to another computer in this private subnet, right? So this is something that you can do with VPC peering. Now, when you are peering up your VPCs, it's important that your IP addresses and CIDR ranges, they do not overlap with each other. So for example, if you have got 10.0.0.16 in here, so you would plan ahead and you would keep something like 10.26.0.0/16 as an IP address for VPC test. So that will not have an overlap between these two IP addresses. And any IP address inside in here will probably start up with 10.16. Okay. So you don't have to overlap your IP addresses because then it would create some sort of networking issues, right? So in this case, your computer at this interface in a private subnet will be able to use VPC peering and talk to this computer. So that is an example of VPC peering. Now, if you don't peer your VPCs, your computer in this private subnet will not know that there's a computer in this, and you will not be able to make any sort of connectivity. So that is something for VPC peering. Now, what VPC peering does is privately connect two VPCs using AWS network. So you make them behave as if they are in the same network. So your computer will act as if it is in the same network itself. So when you're requesting any data from this computer to this computer, they'll behave as if they're in the same network. Whereas the construct is completely different. There it's in VPC one and this is in VPC two. Right? You must not have any overlapping CIDR ranges. So that's what I meant. So when you are starting up with 10.0.0.0 in here, you should have something which is not overlapping. Now, why I selected 26 is probably because number of computers 65,536. This range is outside of that because if you look at the CIDR ranges, so it's very big. So when you do a 2 to the power calculations, so it starts becoming very bigger. Uh, Now, these are not transitive. So what it means is that when you have VPC A and VPC, these two VPCs connected, if you create another VPC, which is in here, and you do a peering from this to this, it does not mean that it connects to the A as well. So for example, if you have VPC A connecting to VPC B through peering, and VPC connects to B connects to C, it does not mean that A also automatically connects to C. The routing does not go through. So each of these VPCs will have to connect to each other in order to for the traffic to flow. So for example, VPC A is connected to VPC B and B is connected to C. But in order for a computer in VPC A to talk to C, it has to go through a specific route through here. So that is what your A to C peering should also be established. This is fine. So, all right. So I think, yeah. So next, we spoke about public subnet. You spoke about private subnet. Okay, something called as NAT gateways. So let's remove this in order to remove some confusion out of the picture. So that is all done. So we've spoken about that. We spoke about peering, and we don't need that. Okay. So let's come back to our original diagram, which is that, and this is what we'll be focusing on. Now, if you see, using this internet gateway, the computers in the public subnet are able to talk to the internet. So for example, if there's some patching required, or if there's an internet connectivity required from a public subnet computer to talk to, it has a route through internet gateway, right? But what do the private subnets do? So for example, let's say you've got an EC2 machine in here, which requires an internet-based patching, right? So there's, let's say if there's uh, let's say it needs to go and connect to your, let me see if there's a Docker hub somewhere. Let's say this needs to go and get something from Docker hub. Okay, how does it go? Because this is now an internet-based repository, right? So any application which is running inside your private subnet will not be able to access your Docker hub or any sort of public libraries. Or let's say it needs to go and access some Python libraries or any sort of internet-based repository it needs to connect to. So it cannot go and connect there, right, at the moment, because it has no internet connectivity. Only the public subnets have the internet connectivity. So there is something which is called as internet NAT gateway, right? And let me just find the. Yeah. So there's something called as NAT gateway. So let's take this NAT gateway, put it in here. So NAT gateway is something which resides in public subnet and it provides internet capability to private subnets. So that's the purpose of NAT gateway. So we'll have a look at how to create all these different components inside. But all your subnets will all your EC2 instances inside your private will first connect to NAT gateway, which will then go and fetch or which will go and connect to your internet-based repositories. So that's how these constructs are. There is one more construct which is important is your routing tables. So your routing tables actually reside inside your VPC, but they are at this point. So you will have these routes, and you will have another routing table. So let's have a router here. So these are something called as routing tables, which will define whether this particular private subnet will have access through internet gateways, and internet gateways are routed through routing tables in here. So this is the whole AWS construct that is very important to understand. So let me just reiterate it. You have AWS in here. Inside AWS, you have got a construct of VPC, which is blue. Inside VPCs, you have got different subnets, and subnets are the IP addresses within the constructs of the VPC. Inside these subnets, you can have your EC2, which are your Linux-based computers or any other operating systems. You have got an internet gateway connected via router, and this is how your any public computer will be able to connect. The public computers will not be able to connect directly to the any of the private computers. If the private computers need access, they will go through your NAT gateway. So let me just write it down. Which will go through your routers. And then they will connect to any sort of internet-based repositories. Right. So,
Okay.
okay. All right. So let's move a little bit forward in this. So this is your whole AWS. Now, as I said, that not all the services are within the boundary of VPC, which is your blue boundary, right? So not all the services are in here. There are some services, for example, like your S3, which is your storage service. Now, this is your like a file storage service. There are some other services like CloudWatch, which is so this monitors all the different logs for alerting and monitoring. So these services, they are they are available outside the VPC. They are within the AWS boundary. So let's keep it as a yellow AWS boundary. They are within the AWS boundary, not still available to the public. Everything in white, which is not colored, that's your public boundary. So they are still within AWS, but they are not still within the boundaries of a VPC. Now, how do these connect? So there's something called as a VPC endpoint. There's something called as a VPC endpoint. So let's say if this is a VPC endpoint. So what you need to do is you can create an endpoint, and this endpoint can then connect to your VPC to your instances. Your instances will connect to this endpoint, And through this endpoint, they will connect to your either S3 or they can connect to your CloudWatch. So this is your S3. We'll go with the details of S3 in subsequent sessions and the details of CloudWatch as well. But these are the services which lie outside the boundaries of the VPC. And you can use these VPC endpoints. So this is you create a VPC endpoint. You can use these VPC endpoints to then connect these services to the other services in VPC.
This is very complex, guys. So even if you struggle, just understand the concept a little bit, and in future we can cover in detail. But this can don't try to implement it right away, I would say.
Yeah. So this is this, and there's another thing which is, for example, your on premises. So let's say this is your on premises office network. So let's mark it as gray or purple. So if you want to connect your AWS to on premises, there is something called as a VPN gateway. So which is at the boundary of AWS, and there's something called as a customer gateway, which will connect with each other. So let's make it as this is your VPN gateway. There's your customer gateway. And through these different sort of gateways, if you have an on-prem computer here, which wants to connect to your AWS, so this is how it would be connecting. So it's like a bi-directional arrow, and then this will connect to, let's say, this private instance. Okay. So if your private instances need to connect to, let's say, your on-premises. Now, on-prem is something which is not on AWS. Your office has hosted a system within there, or your office has your own separate infrastructure, your net infrastructure networks. Now, your on-prem might have a completely separate set of IP addresses, right? So your on-prem might have something, let's say, as it has got x.x.x.x. So that's your IP addresses in here. And if it wants to connect it, so it uses something called as VPN gateway and customer gateway. So let's not get confused too much about connecting your on-prem and your AWS for now. All right. So this is the construct that we'll be talking about. So what we created was we created anybody who is super confused with this, because it's important to understand this kind of networking. Because even as a DevOps engineer, when you're trying to go and create the different infrastructure within all these different subnets inside and then you will have something called as a security group, which I should mention in here. So there's a concept of these two. Oh, come on, send backwards. Let's make it that. And I can't bring it. So let me bring this forward. To front. Okay. There's a concept of something called as called a security group. And inside these security groups are these computers. So that is the whole construct of AWS. I'll repeat it again. So if anybody is confused, we have got this a whole AWS marked in yellow. Inside the AWS, the first construct you create is VPC. Inside the VPCs, you will have subnets. Now, these subnets, depending on the permissions that we give, are classified into public and private. Public subnets are those subnets which have direct access to internet. Private subnet is something which do not have direct access to internet, but internet can be provided by the use of NAT gateways and routers, right? We also have something called as VPC endpoints, which we can use to connect to other different AWS services. And then we have got these different sort of gateways which can connect to on-premise systems. We can also have VPC peering, so we can connect one VPC to another. So this is and that is all is the whole of the networking. And it's important to understand the concept of CIDR zones, the CIDR range, and the CIDR block, which is the number 16 or number 10. So whatever is the CIDR ranges that we have in here. All right. So I think the next part of these slides, I think the next part will be all in on the console. I don't want to confuse you guys more. There are a few more things that we can talk about. One more thing which I can talk about is something called as a concept of transit gateway, right? So if you see in here, so what we did was we have one VPC and we marked it as blue. So let's take it as blue. So we have one VPC, we have another VPC, and we have three VPCs in here. Right. So let's call it as VPC A. This one as VPC B, and this one as, so these are A, B, and C, right? So we can go and do peering between them, or there's another concept, something called as, and let's say we've got one more VPC in here. So 4 VPCs. If you want to connect each of the VPCs, so how many connections will you have to do, right? So if you want to connect all these VPCs together, you will have how many? I think around 1, 2, and these are all bidirectional arrows. 3, and then you will have another this one connecting to B, C, and D, D connecting to A, B, and C. So this becomes impossible, right? So with the more number of VPCs connecting, so there's a concept of something called as a transit gateway. And I think we should have yeah, it's in there. So there's something called as a transit gateway. So if you have a transit gateway in here, if you have a transit gateway, all you need to do is connect that VPC to the transit gateway. And then all the traffic will flow via transit gateway to all these VPCs. And these are all bidirectional arrows. So the traffic flows from both directions. So if you create a new VPC, let's say E, all you have to do is just connect it to the transit gateway and your networking will work. So that is what the purpose of transit gateways. So a transit gateway, the transit gateway is it can provide transitive peering between thousands of VPCs on premises, hub and spoke, star connection. So there are different types of connections. So if you directly connect it like this, it is like hub and spoke. But there are other ways to connect it as well. So it's got like a star connection, and there's also, I think there's a wheel connection as well. So different types of connections using transit gateways. So it works. So there are other terminologies as well. So direct connect, and also we'll go through that in other sessions when we're creating direct connect networks and all. But so let's focus today on whatever we have learned uh, in here. So consider transit gateways, and we work with these, right? All right. So now going to so far what we did, all we did was we created our VPC, right? So I created my prod VPC, and I've got these different dev and test and all these VPCs in here as well. So let's try to create some subnets, right? So the next construct that we have in here, uh, that. So we created this blue region. So let's try to create a subnet. So for subnets, let's go in there and I'll create a subnet. So select a VPC. So the subnet has to be inside the VPC. So I'll select my prod VPC, and let's create a subnet called as my prod subnet, and let's call it as subnet A. Okay. Now you see what I'm trying to do here is I want to create a subnet. Let's call it as subnet A, which is your going to be a public subnet. Okay. And we create a subnet B as a private subnet. Okay. So this is what we are trying to create. So subnet A, we want to create as 10.0.0.0/24. Okay. So we create a subnet A. Availability zone 10.0.0.0/ so that's the VPC CIDR block /16. So if you see /16, so it has got 65,000 computers. Inside that, the first block that we are creating is 10.0.0.0 /24. Now this 24 will contain around 256 IP addresses. It says you 256 IPs. So it's a very big subnet. Actually, when you're actually drawing, so you have to draw your subnets very carefully. And the CIDR ranges which you're allocating, do you really need 256 computers in your public? Maybe not. So in that case, your infrastructure team has to decide and ask the project, do you really need these many computers in the subnet if we are creating it for you? And if that is okay, so you create it, right? So the first one is that, and you create a subnet. Now, creating these subnets, it doesn't cost you anything. So it's all free. So AWS only charges you for the resources that you are using. This is just you are dividing the way in which you want to create your infrastructure. So that's your subnet A. Now, see, when you're creating these subnets, it didn't ask you whether you want to create a public subnet or a private subnet, right? So it still doesn't, AWS still doesn't know what you want to do with this. So let's create another subnet called as subnet B. So this is my prod SNB, right? That's your subnet B. And this is something that you want to create as 10.0.1.28 10.0.10, right? So you want to create with, so Now this one has got only 16 IP addresses, and this is what we wanted. So subnet A has 256 and subnet B has got 16 IP addresses. And then you create this subnet. So now we have got two subnets created. So you subnet A and subnet B, right? So these are the two subnets. Now what we want to do is, so we created subnet A and we created subnet B, right? Now what you want to do is you want to create an internet gateway, because by default, the computers in here will not have an internet access. So because if you create an EC2 instance inside here, it will not have an instance access. So the public interfaces, any public computer will not be able to connect to it. So what you need to do, if you want to create an EC2 instance inside here, which publicly should be accessible, then you need to create an internet gateway and the associate routes with it, right? So let's say you create an internet gateway. So inside the subnets, you've got different sort of options in here. So all we did was we went through VPCs, we went through subnets, we created two subnets. In here, if you see, there are a lot many different items here. You've got routing tables, internet gateways, elastic IPs, endpoints, network ACLs, firewalls. It allows you to create customer gateways. We also had a look at your VPN gateways, right? And then there are so many transit gateways. So each one of them have got their own different menu options, and it's very elaborate. So if you want to go into each one of them, but let's try to first connect an internet gateway. All right. So now, how do you create an internet gateway? So you go into the internet gateways here. You create an internet gateway, and let's say you call it as my prod IGW internet gateway, right? So when you're creating an internet gateway, it still doesn't ask you what do you want to do of this gateway, right? So all it says is that okay, I'll connect an internet gateway for you if you want. So you create an internet gateway, and your internet gateway is created in here. Now, what do you want to do with this internet gateway? If you see in here, so the first thing is when you created an internet gateway, it didn't even ask you which VPC you want to connect to, right? So all it asked was just the name of the internet gateway. And when I created this internet gateway, it just created something, but it is not really attached to any VPC. So I created a my prod internet gateway, and let's try to go and attach it, right? So this will tell you as to which VPC do you want to connect to. So because all it did was it created an internet gateway so far, but it did not attach it to this specific VPC yet, right? So and this is something which is which I'm creating my prod VPC, right? So internet gateway is not yet attached to your prod VPC. So when you go to my prod internet gateway, you do attach it to VPC. It'll ask you which VPC you want to, and then I tell it that you attach it to my prod VPC in here. And now it says that your internet gateway is successfully attached to your production VPC. So theoretically, and even behind the scenes, your internet gateway is attached to the specific my prod VPC now. So these two are attached, right? Now, we're still not there. So we created this internet gateway. We will create an EC2 instance here later on. But now what we need to do is this connection is still not done. So your subnets are not attached to your internet gateway yet because you attached your VPC, but which subnet is attached to internet gateway, you haven't really provided that. So you need to attach your subnet to this internet gateway, and that you would do through routing tables. Now, so the first thing that you need to do, so if you go into in here, all you can do is detach from VPC, manage tags, but you can't do any routes in here. So what you need to do is now you need to go and create a routing table for it. A routing table is a network connection which tells which subnet you want to route the traffic, right? So let's create a route table here. So let's say you call it as my route. Let's call it as just my route to prod. You need to select a VPC, so which is my prod VPC, and you just create a routing table here. Now, your routing table at this point of time is attached just to the VPC. So this router is attached just to the VPC, but it is not yet attached to the internet gateway, right? So all you've done is created that. Now this routing table should get attached to your internet gateway, and I think you need to do it from here. So the first thing you do is you attach it to your subnet, right? So this is your, if you go into the route table, so this is your my routing table prod. You go into actions, you edit the subnet associations, and now you tell it which one is your public subnet and which one is your private subnet. So this is the point where you classify whether subnet A is public or subnet B is public, right? So this is the point where you choose. So if you attach subnet A to this routing table, then this subnet A will become a public subnet. If you attach both of them will become a public subnet, because now you have got a route which is attached to the uh, internet. Did I attach it to the internet gateway, Sanjeev? Oh, I'm just forgetting. So we just created a route with VPC. All right, we'll see. So now what you've done is you attach this routing table to your subnet A and you save it. So your routing table is attached to the subnet. Your subnet is within the VPC. Your internet gateway is attached to this VPC. So you've got an internet gateway which is attached to the VPC, and your subnet which is attached to the routing table, and your routing table is within VPC. So this is how you would configure your routes and subnets. So at this point of time, any instance that you create in EC2, any EC2 that you create in here in this public subnet will have access to the internet. Now, another thing called NAT gateway. So now, because you have subnet B as a private subnet, you will have to create a NAT gateway so that your private EC2 instances get internet as well, right? So for that, you will have to go to your NAT gateway, and your NAT gateways will be, where's the NAT?
It's up only.
Yeah, it's up. So now if you attach you create a NAT gateway. So you say my prod NAT gateway. This you select subnet B, my prod subnet B, right? Because that's what you're trying to do. You've got a my prod subnet B. This is what you want to attach to your NAT gateway. So in here you select subnet B. Connectivity type for the NAT is public and private. So if it's a private NAT gateway, it can't reach the traffic. So you have to make it as a public NAT gateway. You can allocate an IP address to your NAT, and you create a NAT gateway. That's it. So you've got a NAT gateway attached in here, and that would be it. And that
How
is
will you test it?
what we can do is we can create an EC2 instance and we can test it. But before we do that, I just want to check if I want to cover anything else. Any time when you don't want your IP address to change for a resource, so that is where you create an elastic IP. Now, elastic IP, they're expensive. They're not free. So what you can do is when you're creating an EC2 instance, and let's say you are hosting up a website on an EC2 instance. So let's say, for example, you have an EC2 instance here, which is public facing, and you have got something called as, let's say, load balancer. And we will talk about load balancers too. So you've got a load balancer, you've got EC2 machines, and you have got a public computer. And you've got a public computer here, which is trying to connect to your EC2 through a load balancer. Let's understand the concept of load balancers first here. So a load balancer is something which will distribute your traffic. So you've got, let's say you've got applications running on EC2 instances, and you've got multiple EC2 instances which you're running, and you want your application load to be distributed. So a load balancer is something which will distribute your load depending on multiple different factors. So if your EC2 is serving an application, and all these EC2s, there are instances which are serving the same application. So load balancer will decide as to whichever is the healthy instance, it will provide service to that particular instance. So let's say you got a website which is running. Now that website endpoint. So for example, the website is mywebsite.com. So that website is attached to a load balancer. And in here, these are the different instances which are serving your website. So what a load balancer will do is it will distribute the traffic. It will identify which EC2 instance has the capacity, and it will start sending traffic in a round robin fashion or whatever you have defined. So let's say it starts sending the first traffic to this instance, the second traffic to this instance, the third traffic to this instance, and it will keep on rotating. So there are multiple ways in which the load balancer can distribute the traffic. The first one is geolocation proximity.
Like in production, most probably we will be having a private subnet as well, and multiple
Yes.
prods as VPCs as well.
So
So obviously, I'm thinking from a like practical point of view, not just for a sample project. In that case, we will be taking all that are given and or more maybe given in the further classes.
That is correct.
Maybe.
So when you are doing an AWS project, you will be creating all these different interfaces first from the console, but preferably using Terraform. And you can do all of these things using Terraform.
Right. Okay. That's something that we are going to come later in the sessions, of course. Okay. But for that, we have to have an understanding of this whole process.
Yes, you need to have an understanding of
basic frameworks are same.
Correct. You need to have an understanding of this framework even when you are writing up your Terraform code or you're using console, because without this, you will get lost what you're trying to do.
Right. Just a follow-up question. I understand this is a very generalist architecture, but would you say this is the most used in the production, considering you are in the field?
Yes, I would say that.
Okay. All right. Are we missing any other things, even with the increase of complexity or the scalability?
We are missing. We haven't really started yet. So
okay.
Look into the complexity of it. So this is if you ask this in the complexity of 1 to 10, so this is 2 or 3.